Today we are learning to multiply rational expressions, and we're going to start with a little review on multiplying polynomials. Let's take this one. If you use an area model to multiply a polynomial, it looks like this. Okay? We multiply here and here, we end up with 21x squared, negative 6x, negative 35x, and 10. The next step is to combine like terms. We end up with 21x squared minus 41x plus 10. Okay? If you know how to do that, that's going to help you when we learn to multiply radical expressions. Let's start with some very simple ones. Okay? Root 3 times negative root 3, well, that's going to be a negative root 3 squared. Let's move this up. We can take a perfect square out from under the radical. We take the square root of that. That becomes negative 3. Okay, let's try this one. First, this one has an integer in front of the radical. This one does too. It's an invisible 1. So first we multiply those integers. 2 times 1 is 2. Root 5 times root 10. We could write root 50, but it's going to help us if we just keep it as factors, because remember, we got to factor anyway to simplify. So we put 5 times 10. Now look what we can do. We can say that's the same thing as 2 times 5 times 5 times 2. You see a perfect square? Right there, take the square root of that out. Now we have 2 times 5 on the outside. On the inside, there's a 2 left over, so we have 10 root 2. Okay? I'll give you just one more example. Let's take a hard one. Let's say you have negative 5 times negative 2. That becomes 10. Root 6 times root 15. Let's just leave it as 6 times 15. Do we have to factor the 10? No, it's already outside. We only factor what's inside the radical because we're going to look for perfect squares we can take out. 6 we can write as 2 times 3. 15 we can write as 3 times 5. And there's my perfect square right here. I take the square root of it out. So I end up with, oops, let's move this out of the way. End up with 10 times 3 times the square root of 2 times 5. That's 30 root 10. Okay? All right, what happens? Here's the main idea. If you have something that's difficult like this, let's try this one. Just like we did when we were multiplying polynomials, we're going to put one term on each part of the box. Okay? This works, then we would multiply this times this and this times this. Same thing goes on here. We've got 4 plus root 5, 3 plus root 5. Right? Let me ask you a question. Whoops. Which problem most clearly shows the distributive property? This one does. Can you see that what we're doing is we're just multiplying root 2 times root 8 and then root 2 times 4 root 3? Okay. This time I'm going to work the problem out all the way. We begin by writing one term along each section of the box of the area model. Now we multiply. There's an invisible 1 right here, so we do the integers first. 2 times 1 is 2. And then on the inside of the radical, we've got 2 times 10. Now we have to do it here. Integers first. 2 times 4 is 8 on the outside. And on the inside, we're going to have 2 times 2. How can we write that? 2 squared. Now down below here, we've got to simplify. So here we're going to do 2. On the inside, we have 2 times, how can we factor 10? 2 times 5. And here we're going to put a plus sign. We've got 8 as an integer on the outside and 2 squared. Now we look for our perfect squares. This one's a perfect square, comes on out. And here's a perfect square. Take the square root of it to bring it out. So we end up with 2 times 2 on the outside. On the inside, we've got a 5. Plus, here we have 8 times 2. Anything left on the inside? No. So final answer is 4 root 5 plus 16. Okay? Let me give you another example. Let's make it a little bit harder. We've got 2 binomials now. 6 root 7 plus 3 root 2, 4 root 10 minus 5 root 6. Okay? Multiply the integers first. You end up with 24. And then on the inside of the radical, we've got 7 times 10. Okay, let's do this one. Multiply the integers first. 4 times 3 is 12. On the inside of the radical, we've got 2 times 10. Once again, multiply the integers first. Negative 30. On the inside of the radical, we've got 6 times 7. Here we've got, multiply the integers first, negative 15. On the inside of the radical, we've got 6 times 2. Okay. When we did polynomials, we combined like terms. We need to combine like terms here too, but it's really hard to see which terms are like terms until after we simplify. So for now, we just have to rewrite each of these. I'm going to factor a little bit more as I go though. 24 times the square root of 7. How can I rewrite 10 so it's in primes? 2 times 5 plus 12 times the square root of 2. Factor 10, that's 2 times 5 minus 30 times the square root of, can I factor 6? 2 times 3 times 7 minus 15 times the square root of, how would I factor 6? 2 times 3 times 2, but I notice I already have a 2, so I'm going to put it up here as a 2 squared. Okay, let's look for some perfect squares. Any here? There aren't any here. So this one just simplifies to 24 root 70. There is a perfect square here. Let's take that one out. Square root of it. This becomes 12 times 2. And on the inside, we've got a 5 left over. Here, we've got negative 30. Can this factor? No. We've got 6 times 7, which is 42. There's no perfect squares here. Minus 15. There is a perfect square here. This one comes out. Take the square root of it out. 15 times 2. Root 3 left over. Okay, so here we go. We've got 24 root 70 plus 24 root 5 minus 30 root 42 minus 30 root 5. No, root 3. Are there any like terms here? No, I have a root 70, a root 5, a root 42, a root 3. I cannot combine any of those. So this is your final answer. Let's see what else we have here. Let me do one more for you. Let's try this one. I'm going to scroll down to give us a little extra room. Oops, a little too far. There we go. Let's start with black. Okay, 8 plus root 3 squared. root 3, 8 plus root 3. What's 8 times 8? 64. What's 8 times root 3? 8 root 3. 8 times root 3 is 8 root 3. Root 3 times root 3 is root 3 squared. Okay? Let's rewrite them down here and we'll simplify. 64 plus, let's see, I've got 8 root 3 plus 8 root 3 plus root 3 squared. Where can I find my perfect squares? Okay, and no perfect squares here. No perfect squares here. How about this one? This one, you take the square root of it, it becomes a 3. Now look, where can we find our like terms? Which ones are going to be like terms? Well, the 2 root 3's are definitely like terms, right? And this is an integer, and this is an integer. So we can add those up. So our final answer is going to be, let's switch back to a pen. Final answer is going to be 64 plus 3 is 67. 8 root 3 plus 8 root 3 is 16 root 3. Okay, let's try another one. Want a big one? All right, root 10 plus root 6 times root 30 minus root 18. Okay, multiplying. Big radical here. We've got 30 times 10. Here we've got 30 times 6. This box we've got the negative 18 times 10 and negative 18 times 6. Let me scroll down. Okay, let's rewrite this and we're going to do a little bit more factoring as we go. Ooh, I need pen. There we go. Okay. We've got 30 times 10. Well, 30 is 3 times 10. And I'm going to leave that 10 as a 10 because I can see that I have another 10 coming up. That's 10 squared. That makes a perfect square. Let's do the next box. We've got 30 times 6. Can you think of how we can factor that 30 that's going to help us? We could do everything down to primes, but it's going to help us if we factor 30 as 5 times 6. And then I'm going to add in the other 6. That makes 6 squared. Next box, we've got 18 times 10. Well, I know 18 I can factor as 9 times 2. And 10 factors as 2 times 5. So now I've got perfect square, prime. I'm good. How can we factor this one? How is it going to help us? Well, I know that 6 is a factor of 18. So if I do 18 as 3 times 6, then I can add this other 6 on as a square. Okay. Perfect squares come out. Yeah. And here, we take the square roots of them out. This one's going to have 2 coming out. And here's the other perfect square. Take the square root of it out. So we end up with 10 root 3 plus 6 root 5 minus square root of 9 is 3 times 2 root 5 minus 6 root 3. Okay. Let's do this. We can simplify this one. 3 times 2 is 6. So here I've got 6 root